All right, let's get these last 6 problems done. All right, so we left off at 13, I believe. So it says graphing an exponential function. These ones are fairly straightforward, but we'll go through it, right? Let's go ahead and click on it. I believe, right, it gives you some function. It says graph the exponential function, g of x is equal to 1/2 raised to the x plus 2. To do this, plot 2 points on the graph of the function and also draw the asymptote. All right, so we're going to do this first part, and then we'll worry about the domain and range last. Once we have the graph, the domain and range are pretty easy to see. So we have 1/2 raised to the x plus 2. So let's do 2 points. So our function as of right now, come on, there we go. G of x is equal to 1/2 raised to the x plus 2. Okay, now we want to pick 2 points that are just really easy for us to calculate and get nice numbers out of. Right? You can really pick whatever ones you want because I think Alex will help you graph it, but I'm going to pick the nicest x value we have here is x equals 0. Right? When I plug in 0, I get 1/2 raised to the 0 plus 2. Anything raised to the 0 power is going to be 1 plus 2 is going to be equal to 3. So on the side here, we'll write we have a point at 0, 3. So that is step 1. Let's do another point. Now I'm going to pick, it is totally up to you whatever point you want to pick. I'm going to pick g of -1. I'm going to plug in an x value of -1. The reason being is that if I have 1/2 raised to the -1 plus 2, what ends up happening is with the negative exponent, right, this will flip and this becomes a positive 2 now. Plus 2 is equal to 4, right? So I have another point at -1, 4. So those are our 2 points. This is good. Now the good news here also is if the normal horizontal asymptote, which it wants you to graph, is normally 0 for any exponential distribution. That's where it would start. But because we've made this vertical shift of plus 2, our horizontal asymptote now becomes y equals 2. So here's our 2 points. Here's our horizontal asymptote. Let's go ahead. We're going to go back and put this on there. 0, 3, 1, 4, y equals 2. So we have, let's plot some points here. 0, 3. Let's do 1, 4. And we're done with our points. And we'll do a horizontal asymptote at 2. And now if we click this, right, it comes up with our function. Awesome. Now you'll notice for the range, or let's do domain first. Domain is the x values, right? There's no x values that I have a problem with. I can plug in whatever x values I want here. And that's true of all exponential functions. All right, so I get the full domain. Now for range, we're looking at the y values. In this case, we cannot have anything below a positive 2, right? So that means our bottom value is a 2. We're not including it. We actually never touch that 2. And we go all the way to positive infinity. Uh-oh. Which part is wrong? My graph's wrong. What did I do? Oh, I typed in, and no one's here to call me out. I typed in 1, 4 instead of -1, 4, right? So let's go back. Let's plot a point. How do I get rid of some points? Does that mean I got to start all over? There we go. Let's try this again. Almost. -1, 4. Easy mistake to make. And now let's go ahead, put this. Yeah, that looks better, right? It's not supposed to be growth. This is supposed to be decay. Still the same answers though. Still the same for domain and range. Let's go ahead and recheck. And now we're good. Okay. Let's go ahead and move forward. Let's jump back to our list here. On to 14, finding a final amount in a word problem on exponential growth or decay. Let's go ahead and open this up. We're going to need to write down this information here. All right, so we're looking for some key information, then we'll go over the equation as well. An amount of $19,000 is borrowed. This is known as the principal, right? It's borrowed for a total time of 14 years, right? So T is equal to 14. Our interest rate here is 3.5 and it's compounded annually, right? So if we're compounded annually, that's only happening one time per year. And remember, when we get to the equation later on, our interest wants to be written as a decimal. So in this case, 0.035. If the loan is paid in full at the end of that period, how much will be paid? Okay. We do have this calculator on the right. We'll probably put that to use. So 19,000, 14 years, 3.5. Let's go ahead. Let's just write down our information. So P is equal to 19,000. T is equal to 14 years. So 14. And we have N is equal to 1 because it's compounded annually. So N is equal to 1. It only happens one time per year. And our interest rate as a decimal is 0.035. And so the equation that we have here, I'll just write out the equation first, is A is equal to, it's going to be your principal times 1 plus R over N. That's a R over N to the NT. So let's just plug in all of our information here, right? Oh, there we go. 19,000, 1 plus R, which is 0.035, all over 1. You don't need to write the 1 if you already can simplify it. I'm just showing the information because this equation will be used in the next problem. And then N times T is going to be just 14, right? 14 times 1. And so, of course, if we simplify this, we end up with 1.035 raised to the 14, right? And so now we have something where we can just go plug this in. Nothing else for us to simplify. 19 times 1.035 raised to the 14. So we have, let's raise this up a little bit, 19,000 times 1.035 raised to the 14 equals. And so they started with 19,000, and just with this small interest rate, after 14 years, they actually ended up paying back 30,000. This is round to the nearest dollar, so 30,755. Then we're going to go over that equation one more time in our next example. So let's go back. I believe, right? Let's go check this out. There we go. Now the only difference between this problem and the previous one is says they borrowed $8,000. They have an interest rate of 18%. That's very high. It is compounded monthly, right? So that is the difference here. This thing is compounded monthly, so N is going to be equal to 12. Assuming she makes no payments, how much will she owe after 3 years? Would not recommend not paying for 3 years. So T is equal to 3. Our interest rate here is going to be 0.18, and our principal is 8,000, and monthly meaning she paid every month, so 12 months in a year. So let's go back. Let's see if I can remember all that. I believe it was a principal of 8,000. Interest rate was 0.18. Compounded monthly, N is equal to 12 for 3 years. And so we're right back to the original equation where A is equal to P times 1 plus R over N, NT. That's an N, sorry. My N's and my R's. So let's fill in all of our information. And we'll probably need to use the calculator early on. There's not going to be a whole lot to simplify here. 1 plus 0.18 all over 12, and then 12 times 3. And so let's simplify one thing here, right? This will be 8,000. This will be 1 plus, we're not going to even try to simplify this, we'll leave it. And this will be 12 times 3, so 36. Okay. Might have to jump back and forth here. I'm going to worry about the inside. I can easily remember the 8,000. So I have 1 plus 0.18 divided by 12. So let's go to our calculator. We have 1 plus 0.18 divided by 12. Let's just, and you can do it in intermediate steps, right? I can just calculate this, right? Then I want to take this number and raise this to the 36. And then I want to take this number and multiply it by my principal of 8,000. And so after all that, she owes 13,000. So that's like $5,000, $5,673 and some change in just interest alone, right? 673. Round is to the nearest cent. Nice try. Almost got me. 1, 2. Awesome. Okay, let's keep going. What's next? That was our compound interest problem. Converting between logarithmic. Okay. And so we want to rewrite one of them as an exponential. We want to rewrite one of these as a log. I'm going to rewrite this problem really quick. So we have log base 8, 1 over 64 is equal to -2. And then we're going to derive the equation for you. Log base 8, 1 over 64 is equal to -2. Okay, so all we really want to memorize is if we have log base A, and it doesn't really matter what placeholders you use here, of B is equal to C, right? It doesn't matter what you use. This is going to end up being A raised to the C is equal to B. Right, so this is going to allow you to go back and forth between the two. Right, so in our case, our A is 8, our C here is -2, and our B is 1 over 64. All right, so let's go ahead, we're going to highlight this, we'll need it for the other one as well. So 8 raised to the -2 is 1 over 64. And it should be true when you actually compute that, right? Let's go ahead. Log base 8 raised to the -2, 1 divided by 64. Okay, what's our next one? And the other one is 3, 0 equals 1. And so let's go back. 3 raised to the 0. Oh, that's in highlighter. 3 raised to the 0 is equal to 1. Well, according to this, right, our relationship, this means that we would have log base 3 of 1 is equal to 0. So log base 3 of 1 is equal to 0. And let's go ahead and check. Awesome. I think there's one more for this problem, for 15. Converting between, yeah, and it's going to be the same idea here. Now natural logs, I actually prefer to work with natural logs. You can use the nice properties. You also get them with logs, but they're just not as nice to write. So we have natural log of x is equal to 2, and e cubed is equal to y. Natural log of x is equal to 2, and e cubed is equal to, or e cubed, sorry, is equal to y. Okay, so I'm going to deal with the first one. Right, I'm going to use some natural log properties, and it'll kind of be a good reminder. Let's move this down. If I take both sides here and raise them and use base e, what's going to end up happening is that e and natural log are going to cancel each other out, and we're going to be left with just an x. And on the other side, we have e squared. Right, so natural log and this exponential e, or base e, undo each other. And same thing over here, right? E cubed is equal to y. If I take the natural log of both sides, so in other words, natural log of e cubed is equal to natural log of y. Well, by log properties, right, that 3 comes down in front. And now if you go ahead and type natural log of e into your calculator, you'll find that natural log of e is equal to just 1. So our final answer here is natural log of y is equal to 3. So x is equal to e squared. Natural log of y is equal to 3. Nope, it doesn't let you type in natural log. Natural log of y is equal to 3. Let's see if it likes that. Yeah. And we'll keep going. About halfway through here. Translating the graph of a logarithmic problem, this shouldn't be too bad, right? Horizontal, vertical shifts, all very similar with all graphs, right? They already give you the original graph. Again, we like to do the vertical shift first, which says let's go ahead and take this down by 1. And it says a +3 is happening, right? This is our horizontal shift, and instead of going to the right by 3, which is what's intuitive, we're going to go to the left by 3. So let's make sure. 1, 2, 3. It looks like they are going to give you both a vertical and horizontal shift. Graphing a logarithmic function. So it's similar to the exponential one that we did before. It says to do this, plot 2 points on the graph of the function, and also draw the asymptote. Okay. Now in this case, right, remember with the exponential, we had a horizontal asymptote. With the logarithmic, we're going to have a vertical asymptote. And we'll get to that in a second. So we have 1 plus log base 3 of x minus 3. Okay, 1 plus log base 3 of x minus 3. Oh, that's already what I'm on. 1 plus and what do they call their function? We'll just call it f of x, right? Okay, so let's go pick some nice points now. So let's say I'm going to do, and we'll explain this in a second, f of 4. This is going to be 1 plus log base 3, 4 minus 3, or in other words, 1 plus log base 3 of 1. And the property that we need to know is log of anything, we'll just put base a, of 1 is going to be equal to 0. And so our answer here ends up being 1 plus 0 is equal to 1. And we'll circle that. I'm also going to write another property, and this is what we're going to use for our next one. So this gives us the point 4, 1. The other property I want to use here is that log base a of itself is equal to 1. And so the other one that I'm going to use here, if I want to get a 3, right, because I have log base 3, I'm going to need to plug in a 6. And so I have 1 plus log base 3 6 minus 3 equals 1 plus log base 3 of 3, which is just going to be 1 plus 1, or 2, right? So I have another point at 6, 2. So these are my 2 points, right? The only other thing for log is I need a vertical asymptote. Now in my case, right, my vertical asymptote originally for any log that has not been shifted horizontally is going to be at x equals 0. However, because we have shifted this to the right by 3 units, our vertical asymptote now becomes x equals positive 3. Okay, and I think I already have the graph done for us. Let's go ahead and go back. I think I went ahead and put this in, and it's just like the last problem, right? Yeah. So we can see our 2 points, decided to do that ahead of time. It also has our domain and range already written out. So again, looking at the graph, it's easy to see that you can get whatever y values you want, right? You can go positive to negative infinity, the y values representing the range. However, the domain here starts at 3 and then goes to positive infinity. We don't have anything to the left of that vertical asymptote. Let's go back. That was the end of 16. We're getting there slowly. 17. Okay. Now it says exact answers in the logarithmic form. And it says you can use base 10 or base e. I like to use base e. Right, so I have 17, x plus 10, 11, negative 8x. See if I can remember that. 17, x plus 10. I think it's at 11, right? Negative 8x. Let's go double check. We're good. Okay. And it wants an exact answer. Now, I need to get that x to come down, right? And so what I'm going to do here is take the natural log of both sides. And again, you can use base 10, which is the other one they're letting you choose between. And that means by log properties, the x plus 10 will come down. We have natural log of 17. And so we have negative 8x, natural log of 11. And I need to solve for x here, right? Need to solve for x. So first, let's go ahead and distribute this. Right, x natural log of 17 plus 10 natural log of 17 is equal to negative 8x natural log of 11. And so now I need to move these x's to one side, and I need to move everything else to the other. So I'm going to keep this x over here. I'm going to move this one to the other side, so I have to add 8x. And I need to move this one to the other side. So it becomes a negative 10 natural log of 17. And now that I have my x's on both or on one side, I can factor the x out. And then finally, right, I can divide and have x by itself. I'm not going to try to memorize this and type this over, but this would be our final answer that we want to go type in. X is equal to this. I guess I don't need to type it in. We can just verify the solution. Let's go ahead. There we go. Perfect. Finding the time, okay. I think we're doing good so far. Suppose that $2,000, so this is a word problem compound interest, but they're going to want to solve for the time, right? So specific, very similar to what we did before, except now we're going to be solving for something else. So suppose that 2,000 is placed in a savings account, that's our principal, with an annual rate. So that tells us that our interest rate here is 0.1, and it also tells us, because it's annual, that n is equal to, oh, I lied, compounded quarterly, there's the n is equal to 4. Assuming that no withdrawals are made, how long will it take for the account to grow to 2262, which is our final amount, right, or A in this case. And so it gives us the interest rate, it gives us the before and after amounts, it gives us how many times we've compounded it. It wants us to solve for t. All right, so 2,000, 2262, 10%. Let's just write down all of our information. Principal was 2,000. Final amount was 2262. I know we were compounded quarterly, so n is equal to 4. I believe our interest rate was 10% or 0.1, and our t now is the question mark, right? So as a reminder, our equation here this is 2,000. Over here is 2262, and we have 1 plus r, which is 0.1, divided by n, which is 4, all raised to the 4t. And so now we just need to solve for t, right? So let's go ahead. Well, first thing is we can bring the 2,000 over. Can we simplify this? This is going to end up being 1.025 to the 4t. And now if I need to solve for t, I need that t to come down in front. So the only way I can do that is by log properties. So I'm going to take the natural log, and you can take whatever log you want, but natural log is kind of the easiest here. And we're going to end up by log properties, right? That 4t comes down. And so again, we want to solve for t by itself. So now we're going to have natural log of 2262, all divided by 2,000, all divided again by natural log of 1.025, and you could do this next one in one step, but is equal to 4t. And just to save ourselves some step, right, if I want to get rid of the 4, I could also divide both sides by 4. And I have t. So I just need to type this into the calculator. We have natural log, and then we have 4 and our interest rate. Let's see if I can remember all that. Where is our natural log? Natural log 2262 divided by 2,000. So that was our first thing. We're just going to push equals. And now we need to divide that by 4 times the natural log of our interest rate, or 1 plus our interest rate divided by the quarterly. There we go. 1.025 equals. And 1.25, perfect. All right, let's do one more. Don't like going above a 30-minute video, but we might have to. Oh, that was 17, right? This is 18. Finding the time. I'm going to do the half-life one because I think that's the one people struggle with the most. They're all very similar, though. It says astatine-210 is a radioactive substance that decays according to the following function, where Y0 is the initial amount present, and Y is the amount present after time t. It says find the half-life, and I'm going to go over both the half-life and the doubling time. They're both very similar. So in my case, I have Y equals Y0 E, and that is a negative 0.0856. I think I got that right. Let's see. Yes, I did. Okay. Now, I'm going to go over both, right? If it says half-life, what you need to know, half-life, and this should make sense, that if I start with y naught, right, then half-life would mean that my ending amount here is 1/2 of y naught. If I'm talking about doubling time, and I start with y naught, then it makes sense that to double I would get 2y naught. Right, but for right now we are talking about half-life. Right, if I start with y naught, which is my beginning amount, and I want half of it, well, I just want half of what I started with. And so when we substitute that in, right, now instead of y, we want the ending amount to be half of what we started with. And so this simplifies fairly quickly because those y naughts are going to cancel each other out. Right, this y naught here and this y naught here cancel each other out. We're left with 1/2 is equal to e to the negative 0.0856 t. And again, now we're trying to solve for t here. Right, so it goes back to the problem we just had, where I need to use natural log properties. And I'll show this step in case we missed it on the last one. Right, by natural log properties, that exponent up there comes down. And so we have negative 0.0856 t, natural log of e, but we know that natural log of e is just going to be 1. Right, so this is just going to go away. Not go away, but it becomes 1, right? And anything multiplied by 1 is 1. And so now we just need to divide natural log of 1/2 by negative 0.0856. And let's go check. So we have natural log of 1/2 divided by negative 0.0856. Oh, 856. And so this says 8 hours. Let's go ahead and solve. 8.1 hours. 8.1 hours. Perfect. All right, so that's the end of the video, 33 minutes long. Hopefully this helps. If you have questions, I'm about to head to my office right now, and I will see you guys later.